So the first problem, we have x squared minus 2x minus 3 is greater than 0, and it says to solve. Solving is a little bit ambiguous because you're not finding x. You can't say x is equal to 3 and x is equal to negative 1 because it's an inequality. And you don't have one solution. We're going to have an interval that's a solution. So a whole section of the number line will be the solution, not just one answer. So we're still solving it, but my solution will be a range of numbers instead of just one. But if this is solving, Virginia, when you see a problem that looks like x squared minus 2x minus 3, your brain automatically thinks to do what? Factor it. Yes, I'm glad your brain is trained to do that. So factor this, Virginia. What do you get? But your brain is trained to then automatically say, okay, x equals 3, x equals negative 1, because that's what we've always done. But instead of doing that, we're going to create a number line and break our number line up into intervals, because now we need to know what section of the number line works for this equation. And the way you break up the number line is by taking the x's inside, which are really x-intercepts of your graph, and using those to break your number line up into intervals. So not solutions, but instead think of them as x-intercepts. So I have an x-intercept at positive 3. We have an x-intercept at negative 1. Because at the x-intercept, that's the point on the graph where it goes either above the x-intercept, above the x-axis, or below. That's the point where it changes from being up and then it goes down. The x-axis is kind of like that middle area, halfway of your graph. So if I label these points negative 1, positive 3, we now have 3 intervals. So if this is a parabola, and here is my x-axis, visually, you can see the pieces that are above 0 and the pieces that are below 0 pretty easily because it's a parabola. This piece is above 0. The piece on the right is above 0. Everything else is underneath 0. Kind of makes sense. But I want you to be able to prove, okay, cross off prove, verify, because you like verify, that it actually holds true. And that's what this test interval does. So we're going to actually test it to make sure that, yes, in fact, it holds true. And that's what you're going to see is going to start happening as you move on through math. So you can do it. You got a problem up here, a graph, but you're going to be asked to like verify, prove, show, confirm, whichever word you like to use. In order to do that, you have 3 intervals. You're going to pick a number that falls in that interval. So Alice, if I have negative 1 all the way to negative infinity, what would be a number that would fall in that interval? Below. Negative 11. Ugh. Can you pick a smaller one? Just so we can do some.
Sorry.
Yeah, I know. It's okay. I like 11 too. Yeah, that's good. Just because we're going to try and do quick mental math here, and negative 11 makes it a little bit iffy. So, negative 11. Okay, Alice, I'm not sure if I want to call on you again. Negative 1 to 3. How about a really nice number between negative 1 and 3 that would be easy to plug into an equation?
0.
Oh, good. Yes. And then above 3?
4.
Good. Yes. Good, good. That's a good game playing with you there. Good. 59, huh? Okay. So then what you're going to do, again, I know you know what the answer is because I got a picture up there, but we're just going to test to make sure that it works. And it's a quick little test. So negative 2, which is why I didn't want you to use negative 59, we're going to plug into the problem here. So negative 2 squared minus 2 times negative 2 minus 3 is greater than 0. Okay, Alice, I'm going to make you do mental math. Not with the 59, but negative 2 squared is
4.
4. Negative 2 times negative 2 is also
4.
minus 3 is
5.
good. See, you couldn't have done that with negative 59 though, right?
No.
Is 5 greater than 0?
Yes.
Yes. So now I've confirmed that this is part of the solution. That whole area. Once you prove one number works, the whole area is going to work. Now let's check out 0. Well, 0 is easy because 0 squared minus 2 times 0 minus 3. Negative 3. Is negative 3 greater than 0? No way. Put a little line through that. That means it's false. I'm going to X this out to show that it's false. And then one last check here, plugging in a 4. 4 squared minus 2 times 4 minus 3. Brandon, a little bit of mental math for you. 4 squared is?
5 is greater than 0.
Okay, well, he already knows it's 5. Nice job, Brandon. 5 is also greater than 0. So now I've confirmed, verified, proved, shown that this is also the solution. So again, going back to the graph, I know this isn't the exact graph what this looks like, but it's going to be a parabola, so it's going to be similar. So you can see that from -1, or actually negative infinity to -1, that part is greater than 0, which means above the x-axis. From 3 to infinity, that part is also greater than 0, above the x-axis. So when we're solving for inequalities, we now have these two sections, negative infinity to -1, parentheses, because it just says greater than, so it can't be -1, because that's equal to, and then positive 3 to infinity. So we have these two sections on the number line that hold true. All of those values would make this equation or inequality greater than 0. But anything in between -1 and 3 would not work because it's all going to be below the y-axis, below the x-axis. Questions? All right, so I made the second one. I changed it. I don't know what I was thinking with 8, I guess because I wanted 2 square roots of 2 to be a little more interesting, but today just doesn't seem like the day. And a square root of 8. So let's make it 9.
Why would you put down
I don't know, because I thought it would be good to work with 2 square roots of 2. And then I thought this morning, I was like, oh, no, it's not. So we'll make it a little nicer and work with 9 instead. All right, so again it says solve, which instead of solving, we're going to think, what are the x-intercepts? How would you find, or quote, I'm going to put quotes, how would you technically solve a problem like this, Brandon?
You take the square root of both sides.
Yep, take the square root of both sides. So that gives us x plus 6. The square root of 9 is
3.
4.
What?
3 or
-3.
-3. Good. Plus or minus 3. So the x-intercepts are -3 or -9. Thanks, Brandon. So again, I don't want you to think of this as solving. So think of it more as we're finding these x-intercepts. So create your number line. Which one's smaller, -3 or -9? -9, yeah. So -9 and then -3. And then do a little test. So we're going to do a little test here.
So every time we are told to do these sort of
Yes.
are we gonna have to draw the number line?
You will be asked to draw it and show your test intervals. That's the directions will say. Other questions? Alright, so pick easy numbers, don't go crazy. Less than -9 would be like -10. In between -9 and -3, maybe -4. And then bigger than -3, you could say 0 if you wanted to, or you could just say -2. It's totally up to you. Or you could say 9. Doesn't matter. Just a little harder to do mentally. So plugging it in here, -10 plus 6 squared. We need to check if that's less than or equal to 9. -4 plus 6 squared. And then -2 plus 6 squared. So Sabrina, -10 plus 6 squared is 16. Is 16 greater than or equal to 9? Greater than or equal to? Or less than or equal to 9?
Not less than.
No, it isn't. So X it off. Doesn't work, not a solution. Sabrina, how about the next one? -4 plus 6 squared.
It's 4.
And is 4 less than or equal to 9? Yes. So anything in there works. And then Sabrina, the last one, negative 2 plus 6 squared is?
16.
And 16 is definitely not less than or equal to 9. So your solution has to be in between those two numbers, and it would be in between negative 9 and negative 3. It gets a bracket because it says less than or equal to. That's why we get a bracket there. Any questions? So if you had a more interesting graph, the test intervals actually do help. But when you're dealing with a parabola, I mean, like, you're either above or below. So anytime you're below, it's going to be in between. Anytime you're above, it's that left or right. But the graph could get a little more interesting, so not just as basic as that. Any questions? All right. So if you flip the page, we're going to skip the calculator problem. Does anybody have confusions, questions about using the calculator, getting this to graph in the calculator? So let's say this looked like this. Having the calculator draw the 1 and then getting it to shape, and then you picking the correct solution. Are there questions on that? So I'm not going to do example 3, because I'd rather do the rational expression instead of worrying about the calculator right now. But you need to find those two intersection points and then describe those two pieces, just like the absolute value problem. You're just using a calculator to help. Alright, so then if you look at the example 4, this example 4, does it look familiar? Nick?
That was the formal problem.
Yeah, what did we simplify this to become?
Negative 2x plus 6 over x plus 2.
Yeah, so this was the warm-up problem I gave you, and we simplified it. This is called a rational equation. The one thing that has to happen, this side must be 0. And then we have to think a little bit about what it means to have an x in a denominator. So if you have x plus 2 in the denominator, what do you have to remember about x's being on the bottom of fractions? Virginia? It can't be negative 2, because if it was negative 2, what would happen? Right. So when you have fractions and there are x's on the bottom, it can't be 0. Whatever you plug in for x can't make that whole expression 0. So when we go to create this number line for our intervals, there are two things that we're going to use. We'll still use the x-intercepts, and I'll remind you how to find that. The x-intercepts are found by taking the numerator and setting it equal to 0. So an x-intercept, when you have a fraction, is found by taking the top and setting it equal to 0. The other way we get our interval is by finding what solution makes the denominator 0, or what value makes the denominator 0. So I'll say denominator. This morning I spelled this demon. I flipped my M and N. It's really rough in the morning when you're here late at night. Chelsea, how did you feel this morning after being here late at night, waking up?
I had to patrol the gym hallway. It was so hot.
Oh, so you
Yeah.
felt really crappy. Cade probably felt crappy because he was up too late last night doing his English work too.
All I know is it was pointless.
Yeah.
We
So
didn't have to check in.
My brain wasn't quite functioning this morning when I was writing. So the intervals are going to be created from x-intercepts and from the value that makes the denominator equal to 0. So let's go back to this problem here. We have negative 2x plus 6 over x plus 2. And Virginia, I believe it was you who said, can't you do one other step to simplify this? What else could you do to simplify it? And then your parenthesis would become x minus 3. So an x-intercept is found by taking the parenthesis on the top and setting that equal to 0. So if you just take this parenthesis, set it equal to 0, that's your x-intercept. That's the benefit of factoring, pulling that out, because it makes it really easy to find. So our x-intercept is at 3, and then who said the denominator value? Is that Virginia? It was Virginia. What makes the denominator equal to 0? -2. So to get this number line to be broken up into intervals, we're going to use any x-intercepts and then the number that makes the denominator equal to 0. So this is like our undefined value for the denominator. I'll put UNDVALU. See if you can get your number line to work and pick a couple numbers for your test interval. I think we're good now. So we have -2 and 3. There aren't any other numbers because there's just one x-intercept, one value that makes the denominator undefined or equal to 0. So Libby, I'm going to trust that you're going to give me a couple good numbers that we could plug in.
-1. Or wait, I'm sorry. I meant -3.
Okay,
for
-3.
that side. And then I did 0.
Perfect. 0 is a great number.
And 4.
And 4. Okay. So you might want to plug it into the one that's not simplified. Like that might make it easier. Or I don't know, maybe like either one of these. I would pick one of those and plug it in. I wouldn't use the original equation or the original inequality. So you're taking -3 and you're plugging it into one of them. I'm going to plug it into the unsimplified. So -2 times -3 plus 6 divided by -3 plus 2. So just like we did before, is that greater than or equal to 0? Brandon, I heard you say yes. What would the top become?
12.
And the bottom is?
A -1.
Is that greater than or equal to 0?
No.
No.
For some reason my mind went that -2 times -3 equals -6. I'm tired.
That's okay. I understand. So the first part does not work. If we plug a 0 in, we have -2 times 0 plus 6. 0 plus 2. Is that greater than or equal to 0? So on the top we get a 6, on the bottom is a 2, which makes 3, and that is greater than or equal to 0. So this is a solution. And then just checking the last one, -2 times 4 plus 6, and then 4 plus 2. What is -2 times 4, Brandon?
-8.
Plus 6?
-2.
-2 divided by 6, is that less than 0? Or greater than or equal to 0?
No.
That's less than. So that part doesn't work. So just to kind of remind you, like this graph, it looks something like this. Maybe it doesn't look exactly like that, there's something behind me. But that's what it like kind of looks like. So we're looking at the part where, let me shift this a little bit. What do we have in x? Our x value was 3, and there was an asymptote at -2. Okay, so it looks something like this. So that's why we have like that middle section right here. This middle section is greater than or equal to 0. That's why we're kind of finding that to be the solution. So the solution would be from -2 to +3. Any questions?
Shouldn't the -2 have like a parentheses
Ooh.
and a bracket?
Yeah, good call. Why?
Because
I'm
it's
trying to be too
asymptote,
quick.
it absolutely can never be -2.
Nice job. Nice catch. So the -2 should have a parenthesis and not a bracket because it cannot be undefined. It's undefined at that value, so it cannot be -2. Thank you. Nice catch. Other questions? Okay, I am going to stop there. We're not going to start the next problem. I think we'll probably do it as a warm-up tomorrow. Please make sure when you're doing your homework that you show the test intervals. I know it's kind of a pain. But for a problem like this, like it pretty much is necessary unless you plug the graph into the calculator to look at it. Anybody interested in trying 1D or 3B for tomorrow? Brandon, will you be here tomorrow? Yeah.
I'll try 1D.
1D, as in dog?
Yes.
Yes. How about take her for 3B?
Alice.
Oh, Eris said she's gonna try.
Okay.
Thank you, Eris.